Hey guys, welcome back. Going to make a quick video here on the solutions to your 11.1 concentration homework. So if you have any questions over that material or unsure about anything, hopefully this video will provide a little bit of insight for that. So without further ado, let's take a look at the types of problems we have to look at today. So number one here asks, describe the preparation of a 250 milliliter of a 15.0% mass to volume sugar solution. All right, so a lot of times kind of helps identify what we're looking for. We have a volume and we have a concentration. What we don't have is a mass. So we're going to be looking for what mass, we measure mass in grams, of a sugar solution is equal to. Now here's my little trick. When you guys see that percentage sign, convert that into a unit we can work with. If it's mass to volume, convert it to grams per milliliter. Make that percentage. Since we have a number there, we can go ahead and add that in, 15.0 grams per 100 milliliters. That's our 15%. 15 per 100. Again, that percentage is just grams to milliliters. All right, so we now have two numbers to work with, 250 milliliters and 15%. My best advice is whenever possible, and it won't always be, but whenever possible, choose the number, choose the value that only has one unit behind it. So 250 milliliters has only one unit back there, whereas our 15%, this is a double unit, grams per milliliter. So whenever possible, we want to work with just one unit, and this one happens to be milliliters. So we'll take that and run with it. 250, yes, that decimal is important for significant figures. Milliliters, okay, cool. So we've got our problem set up. We know that milliliters has to go on the bottom. We're looking to get to grams. Hey, look at this. This conversion right here will take us straight from milliliters to grams. We just have to make sure we line it up correctly. We put the milliliters on the bottom, the 15 grams on top, and voila, milliliters is canceled out. We're ready to solve for grams. So we'll take our calculator here and take 250 times 15 divided by 100, 37.5 grams of sugar. Let's double check our significant digits. Again, because of that decimal, that zero is important, is significant. So that's three significant figures. The 15.0, again, the zero is significant. It's to the right of the number, and there's a decimal present. So both cases, the zero is significant. That means there's three significant figures, three significant figures. Hey, our answer, three significant figures, 3, 7, and 5. So that's a good looking answer. But here's the thing, we're not done with this yet. It's saying describe the preparation of. So we need to say add water to 37.5 grams sugar up to, and we want a total volume of 250 milliliters, so 250 milliliters. And that is how we answer this particular question. Again, the idea being we can't add the sugar to the water, otherwise we're going to increase our final volume and we'll have more than 250 milliliters. We only want a 250 milliliter solution, not 250 milliliters of solvent. So have to phrase it similar to this as our appropriate final answer. All right, number two, let's take a look at the second one here. Okay, so we've got a solution is prepared by dissolving 2.75 grams of copper 2 sulfate in enough water. Whole thing on here. No. So in enough water to make 75 milliliters of solution. Determine the percent mass to volume of the solution. All right, so this is the type of problem where I think it really helps to start off with your question mark. What are you looking for? Well, we're looking for mass to volume, so that's grams of solute over milliliters of solution. Cool, so that's what we're looking for. Let's see, what do we have here? We have 2.75 grams of copper 2 sulfate. So that's our mass of solute. Well, hey, if we're looking for that on top, might as well put that right on top. Copper 2 sulfate, there we go. There's our 2.75 grams copper 2 sulfate, and we need milliliters of solution down here at the bottom. Look at that, 75 milliliters of solution. They gave us everything right there. Sorry, there should be a 0.0 at the end of that. Try to cram that in here, 75.0 milliliters. Multiply it by 100% because we were looking for a percentage there. Hey, we're ready to calculate. 2.75 divided by 75.0 times 100%. We have 3 significant digits, 3 significant digits. Again, that 0 is important. It adds that extra significant digit. We have a 3.67% solution. There we go. Hey, again, this is an example this is an example of, well, I think it's really important to set your problem up correctly. Allows you to see what you have, what you're looking for, how to set it all up. Sometimes it's all right there and no conversions are needed. So there we go. All right, let's take a look at number 3. Try to get it so my face isn't blocking any part of it. All right, so there we go. 25 milliliters of ethanol is added to 100, and there's that decimal again. That makes those zeros significant. 100 milliliters of water. What is the percent volume to volume of the solution? What is the proof of this solution? All right, so question mark. We're looking for percent volume to volume. That's milliliters of solute per milliliters of solution. So we have 25 milliliters of ethanol and 100 milliliters of water. So ethanol, the smaller value is going to be our solute. So I can go ahead and put that up top. And then here's the issue. 100 milliliters of water is not the solution. You guys remember, solution is solute plus solvent. So our solution is both the 25 milliliters of ethanol and the 100 milliliters of H2O. So it's both of them together. Make sure we multiply by 100%. This is all in one step on our calculator. 25.0 divided by, we're going to open up a parentheses, 25.0 plus 100, close the parentheses, there we go, and then multiply it by 100 for that percentage. Press the equal button, and there we go, we get 20%. Hey, let's double check our significant digits. Always got to make sure we do that. So we've got 3 significant digits here. When we add 25.0 and 100 with a decimal, it's an addition problem. Our last significant figure should be in the ones column. So 125, that's 3 significant digits, 3 in my starting value, 3 in the bottom value. So this one will be 25.0%. 3 significant figures. There we go. There we go. Hey, second part of this. What is the proof of this solution? Well, proof is just kind of a tricksy little thing that some companies do. 2 times whatever your percent concentration is. So we're going to end up with, whoops, not 40%, sorry, 40 proof. There we go. That's all you do to find a proof. Just multiply your percent concentration by 2. All right, there we have it. There's problem number 3. Let's take a look at number 4. Moving right along. Number 4 here. How many milliliters of ethanol are required to prepare 2.5 liters of a 1.50% volume to volume ethanol solution? Well, again, right away, I want to make that this time milliliters of solute over milliliters of solution. So solute over solution. When we're using milliliters, can't do grams over milliliters. We got to make sure we specify solute over solution. All right, so they're asking for how many milliliters, so question mark milliliters of ethanol. Ethanol is going to be our solute, so how many milliliters of solute are equal to, again, we've got two numbers here, 2.50 and 1.50%. We want to work with the one that has just one unit. Look at this as a double unit. If we can help it, we won't always be able to, but whenever we can, let's choose the number that has just one unit, 2.50 liters. Now that is going to be our total solution. Again, since we're working with nothing but volumes this time, it'll be helpful to identify, is this the solute or is this the solution? So I'm going to write that in there. We're looking for 2.5 liters of total solution. We know that liters of solution is going to be on bottom. This won't do it for us. This is in milliliters. So first step, we need to convert liters to milliliters. Pretty simple conversion. I hope we're all pretty familiar with it by this point. And now look, now liters is out of the way, and now we've got our unit milliliters. So now we can use this right here. Again, keep in mind it's a percentage, so that's 1.50 milliliters of solute per, what is that percentage-wise? It's per 100 milliliters of solution. That's 1.50%, 1.50 out of 100. Our milliliters of solution will cancel out. And look at this. We're looking for milliliters of solute. We have milliliters of solute. So we're ready to calculate here. 2.50 times 1,000. There we go. You can see all of it now. Times 1.50 divided by 100. We get 37.5. What's the unit we're looking for? Milliliters of solute. You could say solute. I'm fine with that. You can say ethanol. That's probably what I'll say. More descriptive than just saying solute. Let's double check our significant digits. We have 3 in that value, 3 in that value, so 3 it is. 37.5 milliliters of ethanol. So again, that's telling you if you want 1.5% and 2.5 liters, you'll need 37.5 milliliters of ethanol. All right, moving right along. Number 5. Not too high. Come on back. There we go. What is the molarity? We got a molarity question of 0.00688 grams of cobalt fluoride in 20 milliliters of solution. Oh boy. Okay, well, whenever I see molarity, again, that's big M, which is equal to moles over liters. That's a mathematical value we can work with. They're asking, what is the molarity? So it's question mark, moles over liters. That's what we're trying to solve for. Now I have 2 single units here. Got to kind of think this one through. Milliliters, hey, I can convert that to liters. So I'm going to put that on bottom because we're going to go milliliters to liters. Transfer this into that. So I want this on bottom because I want to end with liters and bottom. And then up top, I've got my grams. So 0.0688 grams, COF2. Put that on top, and I can go grams to moles. We've been doing that for the last 2 weeks. That's not a bad, clean this up a little bit. That's not a bad conversion to make. Again, it's up to you which one you want to do first. Some people prefer to do the milliliters to liters first. That's absolutely fine. I'm going to prefer to go grams to moles first. In order to do that, I need a molar mass of cobalt fluoride. So cobalt CO 58.93320 grams per mole. And then we're going to add that to 2 of the mass of fluorine. So here's fluorine, 18.9984032 grams per mole. And we get our molar mass and calculate it now, 58.93320 plus 2 times in parentheses, 18.9984032. Close those parentheses. There's our molar mass. 96.93. Boy, that's a lot of zeros. 1, 2, 3, 4, 6, 4 grams per mole. Let's double check our significant digits. It was an addition step. So now it matters how many past the decimal. This one goes 5 past the decimal. This one goes 1, 2, 3, 4, 5, 6, 7 past the decimal. Well, that one's long, isn't it? Well, we're going to be limited to just 5 past the decimal in this addition step because of this value here. So 1, 2, 3, 4, 5. That third 0 is my last significant one. I'm going to underline those last 3 numbers. They're there. They hold value, but they are not significant. Cool. So that means we have, I don't know where that 3 came from. We have 96.9300064. I'm going to underline those last 3 grams cobalt fluoride per 1 mole cobalt fluoride. And there we go. We have successfully gotten grams out of there. We have moles on top. Last step, in my opinion, the easiest of the steps, milliliters to liters. And it's a pretty simple conversion. We need milliliters on the top here. That way it divides out, and that gets us liters on the bottom, which is what we want. Hey, there's the advantage of listing out what we want. Get our liters on the bottom, milliliters will cancel out. I'm left with moles cobalt fluoride on top, liters on the bottom. We can calculate, we can crunch, we can come up with the number here, 0.0688 divided by 20, 0.0, divided by 96.9300064 times 1,000. Hit the compute button and we're going to get a molarity of 0.035. Let's double check our significant digits. We've got 3 there. Again, zeros to the left, never count, decimal or not. So just 3. Here we have 3 significant digits. Zeros to the right count when there is a decimal. So that's 3. So our final answer should have 3 digits in it. That 4 is our last significant digit. We look to the number after it. It's an 8. Means round up. So 0.0355 molar. Perfectly fine answer there. Or if you prefer, 0.0355 moles per liter. Either one of these, a perfectly fine answer. You do not have to give me both. Just one will do. And we're moving right along. We're on to problem number 6, the last problem on your homework tonight. How many grams of solute are in 650 milliliters of a 0.28 molar NaNO3 solution? Cool. It's nice when they tell you exactly what they're looking for. How many grams? We're looking for NaNO3. So how much of this material is in 2 values? But look at that big M. That big M means moles per liter. That's a double unit right there. I want to work with the number that has just 1 value in it. So when you're working with percentages, you got to convert your liters to milliliters. Most of our percentages are out of a milliliter. But when you're working with moles or molar, we need to go to liters. So first step, we're going to have to put 1,000 milliliters on the bottom, 1 liter on the top, and now we have converted from milliliters to liters. Next step, is there a way to get to grams? No, not straight away. but we always know how to go from moles to grams, right? All we need is our periodic table. So if we put 1 liter on the bottom and 0.28 moles on top, again, this is our moles per liter right there. That's our molar. That big M is right there, 0.28 molar. Now we're ready. Now we're ready to go moles to grams. All we need is our molar mass of NaNO3. So to find that, we put together 1 sodium. With 1 nitrogen. And we're going to need 3 oxygens. Let's multiply that one by 3. All right, let's calculate that molar mass of sodium nitrate, 22.989768 plus 14.00674 plus 3 parentheses, 15.9994. Close those parentheses, press the compute button, and our molar mass of sodium nitrate comes out as 84.994708 grams per mole. Double check for significant digits. Addition step, so again, it matters how many past the decimal. This one goes 6 past the decimal. This one goes 5 past the decimal. Oxygen just goes 4. So we're going to be limited to just 4 past the decimal. That's 0.8. Need underlined. Hey, at the end of the day, I did all that so I could bring it over here. Again, watch your units. We want moles on the bottom. That means grams are on the top, so I need that 84.994708. And 1 mole on the bottom. And now we got everything lined up. So milliliters canceled out, liters canceled out. Our last thing there was moles of NaNO3. We're left with grams, which is what we were looking for. Hey, there's that advantage. You start off strong, you're going to know when you're done. So we had 650. That's just 2 significant digits there. There's no decimal. So trailing zeros are only significant when there is a decimal, and there isn't. So just 2 significant figures. Divide that by 1,000. Multiply it by 0.28. And multiply it by 84.994708. Press the compute button. Hey, there we go. And just 2 significant digits there. Just 2 significant digits there. We just want 2 in our final answer. So 15 will do. 15 grams sodium nitrate. Hey, there we go. There's your homework. I believe there was a bonus problem, but I'm going to leave the bonus problem for those of you who would like some bonus. So thanks for stopping in. I hope this helped. You guys have a new homework to do. Due Tuesday, I believe. So have a good e-learning Friday, and we'll see you guys next week.